Water Care, a community water development and advocacy NGO, is undertaking a water enhancement and water safety planning project for Thulusdhoo Island in Maldives. This is the GEF Global Environmental Facility Small Grants project being implemented by UNDP, titled Water Quantity and Quality Enhancement and Water Safety Planning in Small Island Water Supplies. This project is modeled according to the WHO Water Safety Planning for Small Community Water Supplies guidelines. This video provides an overview on the current status of water supply in Thulusdhoo Island, which was assessed based on site visits, discussions with focus groups, and relevant material. So far faced several challenges. The first being selection of implementing island. We approached National Disaster Management Center and Ministry of Environment and Energy for selecting the implementing island. NDMC contributed by providing data on the islands that have been provided with disaster relief water during dry weather in the recent years. Water Care held discussions with Ministry of Environment and Energy with the data from the Disaster Management Center and were instructed to make a presentation of the SGF project. We complied by making a comprehensive PowerPoint presentation focusing on water safety planning and the necessary water enhancement in May 2013, following which the State Minister and the Director General of Ministry of Environment and Energy, in consultation with EPA, decided to implement the project in Thulusdhoo Island for the following reasons. Thulusdhoo already has large central storage tanks, for which treatment units proposed in the project can be connected to serve the whole community. Thus, this project available resources would result in a complete water supply model for other islands of Maldives to duplicate. The size of the roofs are adequate to provide full utilization of the tanks of capacity 950 cubic meters near STO go down and 460 cubic meters at the Friday Mosque compound.
Considering the important proximity of Thulusdhoo to Malé and travel convenience for this pilot project with a major resource demand on community training, empowerment and mobilization to effect water quality assurance in accordance with WHO's water safety planning procedure. It is a blessing to have central storage unlike any in the outer islands of Maldives of this population category, and would be sufficient to complete a water supply model scheme for other islands to duplicate. Water safety planning procedure. Assemble a water safety team by engaging the community. This activity will require our core team to travel to the island and hold a stakeholder meeting at the island level. Describe the community water supply system. This activity will be the subject of the first workshop at island level in which all stakeholders participate. The workshop will help to send the message across to a wider audience and secure partnership and ownership across the wider community. Identify and assess hazards, risks and existing control measures. The storage tank near the STO go down has started to develop rust at some points and is in need of painting. It is also necessary to protect the tank site and prevent misuse of the tank facilities. The collation of this information would require coordination and follow-up with different stakeholders, including the EPA. The necessary coordination will be conducted initially by Water Care until the island's water safety team is strong enough to take over these activities. Develop and implement an incremental improvement plan. Monitor control measures and verify the effectiveness of the water safety plan. Stakeholder consultation. We have held discussions with stakeholders, Ministry of Environment and Energy, Environmental Protection Agency, two Thulusdhoo NGOs, Club Sounders and Zwan Group, Island Council, Errol Council and appropriate tradesmen, explaining the project and the expected contribution of the community for the successful outcome of this project. The parties met, were very positive towards the project and agreed to assist in their capacity. Club Sounders and Thulusdhoo Isand Group decided to provide nominations for the water safety planning team using fair and justice procedures giving equal opportunities. Domestic water collection. Private houses have domestic rainwater collection systems supplying fresh water for drinking and cooking, sufficient to last throughout the year except for part of the dry season lasting from January to March. Domestic wells provide water for washing and bathing. Public water supply. The public water system comprises of community rainwater harvesting systems and a desalination plant with water distributed at tap base and harbor. Additionally, there is a desalinated water distribution point at mosque as well as the jetty established by Coca-Cola Company providing free water for the community as well as sale to boats respectively. Public rainwater scheme. Rainwater is collected from STO go down roof from a roof area of 2,100 square meters at the harbour front and stored in an adjacent storage welded steel panel tank of capacity 950 cubic meters, which is distributed to at the site as well as the harbour. Rainwater collected from community center roof of 1,000 square meters is stored at a welded steel panel tank of capacity 460 cubic meters, which is located at the main mosque compound. Water is distributed at the tap bed at the mosque boundary wall. Desalination. Water from the reverse osmosis desalination plant of capacity 15 cubic meters per day, donated by the post-tsunami disaster relief work is distributed by 7 tap bays which is located in different areas of the island. However, pipes at the tap base have been neglected and the RO plant is currently not in operational condition. Desalinated water from the RO system of Coca-Cola Company is distributed at the nearby location. Groundwater. Further based on the technology options proposed by recent World Bank Water Security Assessment, Thulusdhoo also has the advantage of developing sustainable groundwater for public consumption by employing infiltration galleries at strategic areas such as the playground. Groundwater and soil. Thulusdhoo is expected to have a substantial layer of freshwater. Water lens depth varies across the island based on topography. Towards the low-lying center of the island, water lens was reached at 0.5 to 0.6 meter at a high tide. This could decrease to 0.4 meter. Thulusdhoo's groundwater is of moderate quality. There were complaints of smell and saltiness in the inhabited parts of the island. They face major environmental issues related to groundwater pollution and over-extraction due to human activities in the industrial zone. Water quality. Community water supply is known to be tested once a week at the Coca-Cola Water Quality Laboratory. However, there is no continuous water quality monitoring mechanism which this project sets out to implement. Domestic water supply is generally not tested. Common occurrences of toxoplasmosis among the community is suspected by medical personnel to be due to drinking untreated rainwater from public or private collections. This project sets out to treat rainwater and assure quality of drinking water with community engagement and empowerment with emphasis on youth and gender issues. First flush and storage tank overflow is diverted for groundwater recharge via an existing well. Current water quality in the context of the right to water. Water being recognized a human right by United Nations, provision of water with no quality assurance is not sufficient to meet obligations for water provisions of community safe and adequate water for essential needs. By implementing this project would upgrade the community water supply into a full-fledged water supply scheme which can be duplicated. Proposed water treatment system. Since we commenced this project, we have conducted a literature review of an appropriate water treatment for Thulusdhoo. Our conclusion to use ultraviolet treatment followed by ultrafiltration tallies with current international best practice. According to the information provided by Sounders Club of Thulusdhoo, the current population of Thulusdhoo stands at 1,500. Based on the consumption of 10 liters per person per day for drinking and cooking, the essential water requirement is 15 cubic meters per day. Realizing that all the households have private rainwater collection systems to last most of the dry period at 15 cubic meters per day, treatment system would provide surplus water to partially fulfill the requirements of the boats calling at the harbour. Thulusdhoo would then have the attractive option of increasing production to cater to National Disaster Management Centre's requirement for emergency relief at a much lower cost than currently as desalinated water obtained from Mali. Emergency water relief in outer islands. In 2005, with financial assistance of IFRC, the government provided 145 HDPE tanks of 2,500 liters for household rainwater storage. According to NDMC, government of Maldives spent over $2 million to supply 400 cubic meters of desalinated water given to outer islands, averaging a rate of Rupiah 500 per cubic meter. Compare this with average water rate in Mali of Rupiah 60 per cubic meter. Comparatively, the same amount of rainwater could have been obtained for less than Rupiah 10 per cubic meter, considering 60% of desalinated water is spent on fuel for desalination as well as reduction of expenses due to proximity. Thulusdhoo water supply has the potential to become an exemplary water scheme that can be duplicated by other island communities in providing safe drinking water to the public using integrated water resources development concept. This is because Thulusdhoo water supply comprises central storage tanks fed by major roofs in the island with the potential to enhance water supply from other sources such as groundwater and desalination to build water security and resiliency, with the added benefit of being able to contribute excess water for emergency relief by replacing desalinated water currently supplied by NDMC to the outer islands demanding assistance when they run out of drinking water in the dry period.